And concentration.
Well, yes, and exactly. Okay, so let's talk through that stuff. Now that your thoughts are together, people always like to be filmed when they thought first. My physical science class is like, every time I ask them a question, sometimes I ask them to think before you turn on camera. Ready? Are we filming?
Yes, but the stand isn't working.
Okay, well, sorry, Austin and Jolene, if it's a bad video and the stand isn't moving. Try to aim it, like, at the person who's talking, just at me. Alright, so kinetics is the study... Motion sickness? No, not that. Kinetics is the study of the rate of reaction, the speed of reaction, just like velocity is the rate at which something is moving, and you would have like distance over time. Kinetics is the study of the speed of a reaction, so amount of chemical over time. And usually your units are going to be in molarity per second, although there are other ways to measure concentration, so it could be molality or normality over time. We didn't learn normality, did we? If you have a very old professor, you might have to do that. But probably not. I don't know. Maybe sometimes. So chemical reactions occur when your valence electrons rearrange themselves. And for a reaction to occur, there has to be a collision between two atoms. They have to collide. Two things that you need to know. The right orientation, so if they collide like this, then they can react as long as they collide with enough force. If they collide in the wrong orientation, they won't react. And if they collide in the correct orientation but without enough force, they won't react. So the more frequently molecules collide, the better the chance that they're going to collide in the right orientation, and then the reaction will occur. And the more forcefully they collide, the more likely it is that they're going to react. So, as we just talked about, temperature is the factor that most affects the rate of reaction, because increasing the temperature leads to more frequent collisions, so you have a better likelihood that the orientation will be right some of the time, and more energetic collisions, giving it enough force to cause the valence electrons to rearrange. But there are other factors that control rate as well. And what would some of those be? Concentration. And how do you think concentration affects rate?
There's a higher proportion of a certain type of molecule, so there's more of it to react with the other type of molecule.
Right. So would that give you more frequent or more energetic collisions?
More frequent.
Okay, so we're going to have more frequent collisions.
And probably more energetic too. Oh, sure. And they'd get more energetic as they...
Not necessarily. Only temperature controls, because remember, temperature is a measure of the kinetic energy of the molecule, right? And so as temperature increases, the molecules have more energy. As temperature decreases, they don't. So temperature is the only thing that will affect how energetic your collisions are. And people get confused by one of the other factors because it seems like you're giving more energy to the molecules, but it's not necessarily the case. So what's another one?
Surface area.
Surface area. How does that affect everything?
Especially when you increase surface area, especially by the crushing or stirring, there's less space between the molecules, and therefore when you start the reaction, more collisions can occur at that state. Or frequent collisions, therefore.
So let's consider one of the reactants we're going to use in the lab today. Generic. You spend your lab be well. So think of the surface area of this tablet, right? If I crushed it up, what would happen to the surface area?
It would increase.
It would increase, and it would increase by a lot, right? Because if I just put this in, say, acid, and we know that Tums is a base, it's an antacid, and I put it in there, then the acid molecules could only collide with those base molecules that cover the surface of this. If I crush it up, all those guys in the middle then would be exposed to the acid, and the rate would be faster. And that's a mommy. So, you will have more frequent collisions. So crushing is going to lead to more frequent collisions, and I'm actually going to put stirring as a separate thing. Micah mentioned stirring. Stirring is very similar. How would stirring increase rate?
It increases the chances of collision.
Yep. So more frequent collisions. And like think if I either didn't or did crush this, and then I stirred, that would cause some of the acid that's nowhere near it to come into contact with it and give it the opportunity to glide. Especially if I had crushed it, then it went to the bottom of the test tube, right? Its surface area still would be not as much as it could be because some of it would be on the bottom, maybe not getting to any new acid once some had reacted. So stirring is going to, now a lot of students will say, but wouldn't stirring give you more energetic collisions because you're adding energy? But are you really changing the temperature when you're stirring? Technically. Like the tiniest bit, you are adding energy. But honestly, it doesn't change the kinetic energy of an individual molecule so much that it increases the temperature noticeably enough that it really has an effect on the energy of the collisions. So even though it seems like they would collide harder, like, you know, if you're in a pool and somebody turns on a big whirlpool thing and you start colliding with the other swimmers, that's going to be more energetic collisions. Like when you get stirred, if you think of colliding, you're going to think, ooh, more violent collisions. But when you're stirring chemicals, you're really not increasing the net energy of the particles so much that it's going to change the rate noticeably. So really it's only affecting the frequency of collisions and not really affecting the force of the collisions. So anything else that affects rate? Am I forgetting anything?
Volume.
Well, volume, and how does the volume of the stuff change?
If there's less area for the molecules to move around, and they feed each other more.
Right, okay, so now we're talking kinetic theory of matter, and that is essentially changing the concentration, right? If I take, let's say, a gas, because we can't really change the volume of a liquid easily, we can't compress it super easily, we can't compress a solid super easily, but if we change the volume of the gas, what we're essentially doing is changing its concentration, right? There's more gas per area, so it's becoming more concentrated, and so it'll have more frequent collisions. Gas laws tell us that perhaps temperature will also be affected unless we control that factor. So if you do change the temperature, you're also going to add energy there. So temperature, concentration, surface area, stirring. Okay. So make a prediction if you're going to watch in the lab. Which of these factors, temperature, concentration, surface area, or stirring, would have the most effect on rate? Temperature. So when you're writing a lab report, which you're going to do this week, or these 2 weeks that you have, because next week is break, I'm going to look at my lab help sheet and make sure we're all set, because I have some notes that are suspicious in my lesson plan today. Oh, good, we do have questions in here. I'll make sure they're good, though. So what you want to do is take some notes while we kind of add stuff. I'm going to heat up, will you get me some water, please? So we're going to take some notes about predictions first, and then examine what will happen. And Jen, you can turn off the camera now, or pause. Don't turn it off. Can you pause? And
How
then
do you
pick it back
pause?
up? Yeah, I always mess this up.